surprise for you, son.
No, 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 Dad! Oh, you gotta be kidding me.
Yeah, I am. You're not getting a Porsche.
Let me tell you something, son. A driver don't pick the cars. Cars pick the driver. It's a mystical bond between man and machine.
Dear God, what is this?
Our enemy can take any shape. They could be anywhere.
It's a robot. You know, like a super advanced robot.
Alright guys, welcome to Introductions to Transformations. I hope that opening movie or clip kind of got your interest a little bit on what transformations are. And if you think of transformations, you could think of the word transform as something that turns into something else, or in mathematical language, this is how we would define transformation is, and then there are 4 different types of transformations that we'll talk about on the next screen. So follow with me, make sure that you're taking your notes, the notes that we have provided for you, as well as if you would like to take them on paper, you can do that as well. But follow along with me. Everything in red you should write down or define. Okay? So let's go ahead and go over to the next page. And the next page is going to talk about the vocabulary that we need. And the first one is a transformation. And in math, a transformation is an operation that maps a geometric figure, pre-image, or image before the regular image, onto another figure or image. So super confusing, but really all that means is that that image or that shape is being transformed somehow, either moving around in the coordinate plane, or getting bigger, getting smaller, or reflecting across different lines. Okay, which brings about the 4 types of transformations. So if you didn't get this written down, make sure that you pause the video and then write this down next to the word transformation. Okay, and then you're going to keep doing this for all 4 of the other types as well. So just make sure that you're staying up to date so that you have all of this information for when you get to do your homework after the next video. Okay, so the first type of transformation we're going to talk about is called a translation. And a translation, in terms of math, means that it's a transformation that slides a figure from one position to another position without turning. So you might be thinking to yourself, I don't really know what that means. Well, let's look at it here on the coordinate plane. So let's take this triangle, say this is where the triangle is on the coordinate plane, and say we want to move it, right? We want to move it maybe like 1 square up and then 1 square to the right, right? That's a translation. So the shape didn't turn, it didn't do anything except for move or slide around on the coordinate plane. So I can move this anywhere I want, and as long as the shape stays the same place that it's at right now, or the same size that it is right now, then that's going to be a translation. Okay? Now let's go to the second form. So the first one's a translation. The second type of transformation we're going to talk about is called a reflection. Okay, and a reflection is a transformation where a figure is flipped over a line. Okay, that line could be the x-axis, it could be the y-axis, it could be just one of the lines on the coordinate plane, but it's some sort of transformation where a figure is flipped over a line. Okay, make sure that you guys are writing down the definitions to these words. So let's look at what maybe a reflection might be. So a reflection that we're really used to is like looking in a mirror, because that's a reflection of ourselves. So let's take this triangle here, place it about right there. And let's take this triangle and put it the same distance away from that y-axis over here. So if you see, this triangle is like looking at itself here in the mirror. This is a reflection across this axis, the y-axis, the one that goes up and down. So that's what a reflection looks like. The next one is called a rotation. So let's look here, and your textbook defines a rotation as a transformation where a figure is turned about a fixed non-moving point. Okay, so you might be thinking, well, what does it mean to have a non-moving point or have a moving point? So let's look over here. Let's say I take this triangle here, and we'll just put it right here. Okay, and then let's say we take this shape and we start right here at this point right here, and we'll rotate it. Say we want to rotate it, it goes all the way up, rotating, 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 keeping this point still. Okay, if I rotated that straight up or straight around that point right there, 90 degrees, it's going to go right here. Okay, 180 degrees, it would then move all the way over, and this would actually rotate, and let's say it turns around a little bit, 90 degrees more, and now that's 90 degrees. Okay, so that's a rotation. We don't really need to have it all the way down pat quite yet, just because we're not going to get into rotations until probably about midweek to maybe even next week. Okay, and the last type is called a dilation, and we've talked about dilations in the past. And a dilation is a transformation that enlarges or reduces a figure by some certain scale factor. So the scale factor could be 1/2, it could be 2. Remember, if it was a number that's less than 1, then the original figure is going to be smaller than it originally started with. And if it was multiplied by a scale factor of like 2 or something greater than 1, then the shape is going to be bigger than its original size. So let's look and see. So if I go over here, say I keep this triangle right here, I like that, and then take this triangle, as you can tell it's obviously bigger, and this would be like a dilation of that figure. So like if we wanted to take this and say I wanted to make it bigger, I'd keep making it bigger and bigger and bigger, and notice how the sides are kind of staying the same as well. That's because it's being times by a scale factor, so it's getting bigger proportionally. The sides still form those proportions. So if I had this and then I had maybe that smaller one in the middle again, and I were to figure out what their side lengths were, I could find out that they are similar figures because they form a proportion. They have proportional sides. Okay, so those are the 4 types of transformations. I'll show you guys again in case you did not get those written down. Make sure that you pause the video and get these different vocabulary words written down. Okay, thank you for watching, and I hope you all the best. Thank you.